In this video, we will cover on 1. Symbol 2. Construction of photodiode 3. Operation of photodiode 4. Characteristics of photodiode 5. Application of photodiode. What is a photodiode? A photodiode is a type of semiconductor-based photosensor or light sensor that is used to detect and measure the intensity of light. It is essentially a light sensor that generates an electric current when light falls on it. The phenomenon through which the light energy is converted into electrical energy is called the photovoltaic effect. A solar cell or solar panel consists of an array of photodiodes, also called photovoltaic cells, that convert solar energy into electrical current. It is a semiconductor device made from a p-n junction, a p-type semiconductor, and an n-type semiconductor material is joined together with an additional intrinsic layer between them. It is designed to operate in reverse bias conditions, i.e., the p side of the photodiode is connected to the negative while the n side is connected to the positive terminal of the battery. The junction is exposed. Using a window lens for the incident light, the electric current is generated that is proportional to the intensity of the light falling on it. This phenomenon is called the photovoltaic effect.
Symbol of photodiode.
Symbol of a photodiode is exactly like an LED light-emitting diode with rays of light falling on it, as shown in the figure below, anode and cathode. The anode is the longer terminal while the cathode is the shorter terminal. Next, let us look into the construction of photodiode. Working of a photodiode. So how does the photodiode work? A p-n photodiode is similar to a conventional p-n junction diode. When a p-n junction diode is reverse biased, the depletion region widens. Minority charge carriers are generated that constitute the reverse current of the diode. This reverse current is directly proportional to the applied reverse voltage. Similarly, in the photodiode, there is a built-in potential difference across the depletion region. When a light ray or photon of enough energy HV greater than the energy gap EG falls on the junction of the photodiode, it dislodges or removes an electron from its valence band into the conduction band. The electron left an empty space called a hole. Thus, electron-hole pair is generated. This phenomenon is also called the inner photovoltaic effect. Under the influence of an inbuilt electric field, the electron and hole moves in opposite directions, i.e., the electron moves toward the cathode and the hole moves toward the anode. The current thus generated is called photocurrent, and it is directly proportional to the intensity of the light. In photodiodes, there is still a flow of current even when there is no light source or photons falling onto its junction. This current is known as dark current. It is extremely small in microampere. It is the unwanted current in reverse bias that varies directly with temperature, and it must be reduced to have increased sensitivity of the photodiode. The total current of any photodiode is the sum of the photocurrent and the dark current. Now, let us look at some modes of photodiodes. A photodiode can operate in following three modes. They are 1. Photovoltaic mode 2. Photoconductive mode 3. Avalanche diode mode. This mode is also known as zero bias mode, as there is no biasing or external voltage source connected to the photodiode. When light or photon hits the depletion region, electron-hole pair is generated that moves in opposite direction away from the junction, under the influence of the inbuilt electric field. As a result, a current is generated. If it is connected in a closed circuit, or a potential difference is generated between the cathode and anode if it is an open circuit. In the case of an open circuit, a forward voltage proportional to the light intensity falling on the active region is generated across its anode and cathode. This voltage is in forward bias mode as the potential at the anode is greater than the cathode. In the case of a closed circuit, a forward current flows through the circuit. This forward current is equal to the sum of photocurrent and dark current. This phenomenon is known as the photovoltaic effect, and it is mainly responsible for the operation of solar cells. Next on the list is photoconductive mode. In photoconductive mode, the photodiode is reverse biased. Its anode is connected with the negative terminal and the cathode is connected with the positive terminal of the battery, or the cathode is at higher potential with respect to the anode. Therefore, this mode is also known as a reverse bias mode. Due to reverse bias, the depletion region expands and varies directly with the increase in reverse voltage. Due to the large area, more charged carriers are collected more quickly from the junction. In photoconductive mode, apart from the photocurrent, there is another current called dark current in the reverse direction. Dark current is due to the reverse bias in the absence of light. Avalanche mode. In avalanche mode, the photodiode is connected with high reverse bias voltage. The high reverse voltage increases the depletion width and the potential across it. Due to high potential, the electron-hole pair flows with maximum speed, hitting more atoms in its path, resulting in more photocurrent. Therefore, avalanche mode has high internal gain and responsivity. Photodiode circuit. When the photodiode is used in an external circuit, it is mostly used in reverse bias conditions. Photodiode cannot power any electronic device, as the current generated by itself is extremely small. Therefore, a power source is used to increase the current supplied to the load. Now, let us take a look at the VI characteristics of photodiode. The VI characteristics curve of photodiode shows the relationship between the voltage and current of a device. The horizontal axis, or x-axis, represents the voltage, while the vertical axis, or y-axis, represents the current through the device. As we know that photodiode operates in reverse bias, therefore the graph is between the reverse voltage and the reverse current. The reverse voltage is represented on the negative x-axis, while the reverse current is represented in microamperes on the negative y-axis. The reverse current does not vary with a change in the reverse voltage. However, the reverse current increases with an increase in the intensity of the incident light. At zero light intensity, or no light, there is no significant reverse current, except for a very small constant current called the dark current. By increasing the intensity of light, the reverse current increases linearly. What are some of the advantages and disadvantages of using photodiode? Advantages are: 1. It operates on light energy. 2. It creates very low noise. 3. It has very low resistance. 4. It operates on low voltage. 5. It is cost-effective. Some disadvantages are: 1. The active area is relatively small. 2. It has lower sensitivity than other components. 3. It requires an external power source to supply sufficient current to a load. 4. Thermal noise greatly affects its performance. What are some of the applications of photodiode? Photodiodes are basically used to detect and measure light intensity. Therefore, it has numerous applications in almost every field. Here are some applications of photodiode.